knew that the radio altimeter problem was one of their highest issues with regard to maintenance.
16 of those altimeter repairs were made to the plane that crashed in February 2009. If the problem was so widespread, investigators wonder why it hadn't caused serious problems before this accident. They don't have to dig too far back to find out that in fact it had, on this very same plane.
On 2 recent flights, they had the exact same problem.
Twice in the 48 hours leading up to the accident, the radio altimeter showed a negative reading, putting the plane into retard flare mode. Both times the crew noticed the problem, disengaged the auto throttles, and brought the plane in for a safe landing.
You just disconnect it and fly the airplane.
In the months after the crash, other operators come forward with similar stories. In Australia, in the Netherlands, in Canada, in Austria, pilots report their 737s going into retard flare mode when the left radio altimeter showed a faulty reading. Each of those crews reacted the same way. They disengaged the auto throttle and pushed the power back up manually. They all landed safely.
Things are going to break on an airplane, and usually you're able to identify that and take that out of, make it so that it's not a threat for the landing.
In 2008, Boeing received a whopping 2,569 reports of faulty radio altimeters on their latest 737s. But very few of those cases involved the plane going into retard flare mode.
Hardly any reports at all.
Boeing also tried but couldn't find the cause of the failures. They concluded that the radio altimeter problem was not a threat to safety because the 737 gives off enough warnings so that crews can intervene and land safely. In fact, in every instance where the radio altimeter failed, crews were able to recover. Turkish Airlines Flight 1951 seems to be the one exception. Investigators still don't know why.
It really got us wondering of what happened. And that's when we started to look really closely at the actions of the flight crews while it was on that final approach in less than 1,000 feet.
Finally, as investigators again revisit the last minutes of Flight 1951, the circumstances of the tragedy become clear. They see a remarkable sequence of events that transpire to bring down this plane.
So, what was happening when the plane went into retard flare mode?
They discover that the plane went into landing mode and pulled back power at the worst possible moment, exactly as the crew was descending to meet the glide slope.
It masked what was actually happening.
As the crew configured their plane to drop down to meet the glide slope, they expected the plane to slow down as part of that maneuver. But the plane was actually slowing down because the computer was in landing mode. That's why none of the 3 pilots said anything about the throttles moving to idle.
It was insidious. Where it first captured in the retard mode, it didn't hurt them at all because they were actually high and they were a little bit fast. And the pilots actually wanted the power back anyway. In fact, the throttles may have already been in the flight idle mode as they were trying to get down and slow down.
The trouble starts here at 8,300 feet, 13 miles out from the airport, minutes before the crash.
Amsterdam. Turkish 1951, descending 7,000, speed 250.
Turkish 1951, descend to 4,000. Speed okay for ILS 1B. Right.
Radio altimeter.
Would the crew have known that because of that radio altimeter they would have gone to a retard flare mode in the throttles? No.
It was a common problem at the airline, but the crew couldn't see the risk it posed this flight.
We have an airplane that was malfunctioning in a very minor way, but in a way that, if not caught, could and did metastasize into something much more virulent.
Turkish 1951, descend to 2000.
2000, 1951.
Turkish 1951, left heading 210, clear approach, 18 right.
Left 210, cleared ILS, Turkish 1951.
Now left at 210 degrees, maintaining 2,000 feet, brings the flight in right here, 5.5 miles out. We now have to intercept the glide slope from above.
At 2,000 feet, with the glide slope below them, the pilots have to reduce their speed while descending steeply.
Speed 140.
They believe the throttles are moving back for the descent to the glide slope. In fact, the auto throttle is slowing the plane down because it's gone into landing mode. It will continue to slow the plane until it stalls.
What we found is that when the flight crew was doing their before landing checklist, each one of them was doing something while they should have been monitoring their airspeed.
For the next 100 seconds, no one notices what's happening. Until it's too late.
Established altitude set.
1000.
Check.
Flaps 14.
Speed set.
The experienced pilot recognized that the first officer was probably a little bit behind on the approach, so he calls for flaps 40 and moves the lever, informing the first officer that he has done so. He's trying to help the first officer catch up to the position of the aircraft.
Speed brake.
Speed brake armed. Green light.
One thing at a time. Landing gear.
The plane is now 700 feet from the ground.
Gear down. 3 green.
Flaps.
Flaps 40. Green light.
In their haste to complete their checklist, none of the 3 crew members noticed the warnings that their speed is dropping dangerously. First, a red bar appeared on their flight display. Then, when the airspeed continued to drop, a flashing box appeared around their actual airspeed to draw the pilot's attention to it. At this point, no one sees either.
Cabin report confirmed.
The aircraft is now 600 feet from landing.
When things start changing colors, it's a warning to you, it's a caution to you that you're approaching the limits of the aircraft.
Missed approach. Altitude set.
500.
So all of these indications the crew has in front of them saying that the aircraft is slowing down. During that time, they were still completing their checklist.
Of course, the aircraft is getting closer to the ground.
In fact, it's less than 500 feet from touchdown.
And right before the stick shaker started, the captain told the safety pilot,
Please warn the cabin crew.
Cabin crew, take your seats. Speed, sir.
I have control.
By the time they advanced the throttles to full power, it was unrecoverable. They were too low for the engines to catch up.
And that's it. It's now too late to save this plane. They all knew about the altimeter problem, but knowing didn't help.
Boeing also didn't foresee the potentially deadly effect of a faulty altimeter. But on February the 25th, 2009, it triggered an unusual sequence of events that brought down a jetliner and killed 9 people. The official report into the accident blames it on a convergence of circumstances.
There is never ever just one cause to an airline accident. It simply doesn't exist. Maybe someday God will swap one out of the sky, but until then, there's never one cause.
The Dutch report also points out that Boeing could have realized the problem with the radio altimeter system could have had an impact on safety. Given that no one foresaw how that failure might cause a crash, the Turkish Airlines accident raises a big question. Are airplanes becoming too complex? Investigators have determined that Turkish Airlines Flight 1951 crashed mainly because the pilots didn't recognize the consequences of the warnings they were getting.
Turkish 1951, descend to 4000.
This is not the first plane to crash because the crew didn't understand what their plane was telling them.
Our problem is not the automation. Our problem is the depth of the training and the ability of the human beings to recover from mistakes made in interfacing with the automation.
Mika Ensley studies the relationship between pilots and technology.
We haven't really designed the automation to take best advantage of what people do well and take away the parts that people don't do well.
In 1996, the crew of an Aero Peru 757 crashed when the pilots couldn't decipher contradictory warnings about their altitude and airspeed. The plane flew into the Pacific Ocean. 61 passengers and 9 crew members were killed. In 1995, the flight management system on a Boeing 757 could and should have steered the plane to a safe landing in Cali, Colombia. But a last-minute change to the flight plan meant the crew had to reprogram their computer. They mistakenly entered a course that took them headlong into a 9,000-foot mountain. 159 people died in the crash.
The cautionary tale here is that we can get this equipment, we can get these silicon-based units, if you will, so sophisticated that we can't talk to them effectively. And when they go berserk, or they have a problem, or we misprogram them, we end up putting ourselves and our passengers in danger while we're trying to figure it out.
NASA is working on something called the Integrated Intelligent Flight Deck. It's a project aimed at helping humans better use the technology that surrounds them in the cockpit.
They're looking at automated flight manual systems, voice recognition systems. They've developed new kinds of microphones that are bone-conducting chips. They're developing new displays for understanding the ground environment, for being able to detect where other aircraft are in the environment.
What some researchers are finding is that the best technology shouldn't replace pilots, but work with them.
Really integrating people with technology more effectively has to do with designing the displays so that you can really understand what it's doing, and you can make it simpler to understand how to make it do what it is you want it to do. You shouldn't have to push 16 buttons through 8 levels of menus to figure out what's going on with the system. It should be integrated and presented effectively. It should be as easy to communicate with as the person next to you.
Boeing and Airbus, the 2 largest manufacturers of passenger planes, take very different approaches to the relationship between humans and technology. Airbus gives the flight computer much of the decision-making power in the cockpit.
In their view, this is a way to prevent a lot of human errors by making sure the airplane doesn't do something that's going to cause a crash, even if the humans want it to.
But Boeing has a different view. Its philosophy is to provide information to pilots and have them make decisions.
Having more information is better for the pilot than having the pilot in the loop, in the equation, so to speak. I kind of like that.
Airbus will argue vociferously and in continuous fashion that that view is archaic and incorrect. I think the jury is still out.
The final report into the Turkish Airlines tragedy blames the crash of Flight 1951 partly on a failure of technology.
The erroneous radio altimeter data caused the autothrottle to go to an improper mode that is, of course, not a good situation.
The cause of the radio altimeter failure was never uncovered. The Dutch investigation asks Boeing to improve the reliability of the system.
We learned a lot about the radio altimeter system and how it affects the autothrottle system. Boeing is currently working on system improvements to prevent this type of autothrottle event from occurring again.
But the report also faults the crew for not noticing that their airspeed was dropping dangerously low, in spite of the fact that there were 3 pilots on board.
Forget that you got an autothrottle. You look at the airspeed, and you look at the altitude. You look out the damn window if you want to, but airspeed is a crucial component of staying alive in an airplane. And you always need to know what your airspeed is.
But to Mika Ensley, the crew's failure to monitor instruments is entirely understandable and may be more the fault of the instruments than the crew.
It's actually very difficult for people to be monitors of automation. One of the things that people don't do a good job of actually is monitoring. We're very good on-the-spot decision makers. We're very good at coming up with creative solutions to problems, but repetitive monitoring is the kind of thing that actually people aren't very good at all. So what we have to do is design automation to work with people in a way that keeps them more actively, cognitively involved and in the loop, and not just monitoring a piece of automation to say, is it doing what it's supposed to be doing?
Who's the ultimate computer? The pilot, the individual who should be able to say, I don't know what this thing is doing to me, but I'm punching it off and flying the airplane. Fly the jet. Probably the smartest thing we ever learned to say in our training in the airlines. Fly the jet. Do that first or nothing else counts. That's what they forgot to do.
Don't miss Liquid Bomb Plot, the true story of a surveillance operation that foiled a terrorist threat. Brand new next Monday at 9. Stay tuned for more drama in the skies.